Hello and good morning. My name is Akash. Welcome to one more session of C-SPAR webinar series where we have been showcasing various latest firefighting technologies from C-SPAR. Viewers, thank you very much for taking out time and joining us today. Today's session is about a unique fire suppression system which is in the category of in-panel fire protection system, which is a queue-based suppression system, which is also known as CQRS, that is C-SPAR Quick Response System. Before we start the session today, let's have a little introduction about C-SPAR. C-SPAR today is a fast emerging global fire safety organization. Having in India since more than 2 decades, we are making inroads to all across the globe. Our demonstration and display zone is ready at UK. The product portfolio of C-SPAR is a complete range of fire safety solutions, starting from fire extinguisher. In fire extinguisher, we have got powder-based, gas-based. Then we have got water-based fire extinguisher, automatic fire extinguishers. In one more category of micro suppression system, we have got suppression system for small enclosure like LPCB and fuse box and electrical panel protection system. Then we do have also room flooding system where we have both gas and water-based variant. The kitchen wood fire suppression system is also there. Commercial kitchen system also there, which is both the wet chemical version and the water-based technology. C-SPAR, we also give more importance to the design part. We have our own in-house designer who designs the product as per the guidelines, and then there are experts who suitably choose the firefighting agent for the right application. Because all these range of products are manufactured in our state-of-the-art manufacturing facility here in India. This production facility is one of the most advanced, in terms of technology to be found anywhere in the world. And this facility is also fully complies to the factory production control, requirements. Now, this whole range of C-SPAR fire suppression system or all the products conform to the highest global standards like EN3, EN1866, the LPCB, the BSI guide mark, and the MED, PD. Also, we use the process certifications like ISO and OSAS are in place. Now, coming back to today's session, which is basically on an electrical panel queue-based suppression system. So I will take you to our demonstration area where our technology expert Pranav Devan will join us for the demonstration. He will explain you the product, and we will have a live demonstration, and post that we will have all our question and answer session. So Pranav, over to you.
Hello Akash, hello viewers. My name is Pranav Devan. Today we're going to give you a very brief insight into this flagship technology from C-SPAR. CQRS and C-SPAR Quick Response System has a key component called heat sensing tube. This heat sensing tube is a modified polyamide, and this flows through the system and senses the flame and extinguishes the fire. The heat sensing tube is connected, or the way it is used in the system dictates how we categorize the system. So we have two categories, the direct and the indirect systems. For the direct system, Akash, the heat sensing tube is connected to the valve.
Okay.
The heat sensing tube will burst open as soon as it detects a fire, and the extinguishing agent pressurized with in the cylinder would come out from the same miniature hole.
Okay.
This would be the direct.
So that therefore it is called direct. Okay. What is the other version we have?
The other version would be the indirect system, where the heat sensing tube is connected to the head of the valve.
Okay.
Here the tube just detects the fire and depressurizes, facilitating the opening of the valve, and the extinguishing agent then comes out through a separate port, which is quite bigger.
So the discharge line is different.
Discharge line is different. Okay. So in this way, we can also use powder as extinguishing agent.
So in the direct version, what are the firefighting agent we are using, Pranav?
See, let's look at first understand the application area.
Okay.
So if we have to look at the application areas, we will have all kind of CNC machines, all kind of electrical panels, okay, injection molding machines, UPS panels, your server racks, your switching panels.
All enclosed area.
All enclosed areas. Plus, you can also use the indirect system in, your commercial vehicles like trucks, buses, cars, and then also you can use it in heavy transport material, transport equipment like ships, cargos, and aeroplanes.
Okay.
Okay. But as you coming back to your question, like what kind of variants we have in the direct system? Okay, we have 2 kg, 3 kg, and 4 kg in fluoroketones.
Okay.
Okay, and 2 kg and 4 kg in HFC 227EA, and 2 kg and 4 kg again in HFC 236FA. These are those variants which are certified by LPS or LPCB as per LPS 166.
Okay, that's the standard for
That's
this.
the standard for this.
Okay.
Plus, we also have the sizes of 6 and 9 kg. In the same way.
Okay. And indirect version?
For the indirect version, we have in gas, or we have the HFC 227EA, then we have MAP 90 and fluoroketone in 246 and 9. Okay. There's another partition into direct and indirect system called the low pressure and the high pressure system.
Okay.
And this is only to how the gas has been stored within the cylinder. So if it's a low pressure system like a gaseous system which is at 15 bar, it is called the low pressure system. And if it's CO2 which is stored at high pressure, we have 2 and 5 kg CO2 cylinder.
Okay. So since we have already explained the system, why don't we see the live installation so that they will understand it better?
Very well, Akash. A live installation will.
So this is a direct.
It is a direct system.
Okay.
And if you look at over here, there's a we have a pressurized agent cylinder. Okay. And to this cylinder, we have a direct low pressure valve attached to it. We have an integrated ball valve in this system. Okay. And this position of the ball valve can be monitored at all times. Okay. This helps in detecting and increasing the reliability of the system.
There is less chances of leakage because
Less chances. It is integrated. So this is how it happens. You have a pressurized agent cylinder. To this, we are connecting the heat sensing tube. The heat sensing tube flows unobtrusively throughout the risk areas.
Okay.
And you can cover multiple partitions within the panel.
Okay.
Okay. So the same tube is protecting the whole panel in such a way.
Fine.
Okay.
So here, as you said, this tube only detects the fire and extinguishes
the
fire.
Okay. So the tube is pressurized and it is equalized to the pressure within the agent cylinder. As soon as there's a fire, there's a miniature hole which is created. The agent will flow directly onto the fire source and extinguish it.
Okay, let's see the indirect.
In the indirect system, as I told you before, the heat sensing tube is again connected to the head of the valve. The valve will be closed till the time the heat sensing tube is pressurized.
Okay.
Okay, we use dry nitrogen to do that. The expulsion of the gas would be through a separate line.
Okay.
Okay.
So we can just see it from inside. The tube is there, which is to detect the fire, and there is a separate discharge, pipeline, and nozzles are there. Right, Pranav?
Yes.
Okay. So what about this, response panel?
Akash, as per so this system is totally independent. Okay, it does not require any external help to operate. It's a pneumatic system. We have a response panel or a monitoring panel which monitors the health of the system. Now, if we were to look at, if the valve is closed or open, this panel can, tell you about that, warn you about that. It can monitor the pressure within the HSC.
This can be also integrated with any,
third-party devices.
Yes.
It can be integrated to your fire alarm. Okay, or if you want to do any other kind of, integration as into biometrics and all that can be done through, non-potential contacts within the system.
Since now we have seen the installation, let's see the system in action with a live fire. Okay, why don't we light the fire, please?
So we're going to see the indirect system first.
This is direct.
This is the direct system first.
Okay.
So as you see, the fire started, and now we are waiting for.
At what temperature, Pranav, this?
About 150 to 180 degrees centigrade. How fast it operates. a button to control response time of the alarm. Give the alarm. We'll give you the alarm now, and you can show the miniature hole which has been created.
So this is what the direct system operates.
Direct system. This is how the direct system operates. Okay. Let's look at the indirect system.
Let's look at the indirect system.
Again, we are simulating a fire inside.
Let's light a fire. So in indirect system, the discharge will happen from the
nozzles above.
Separate pipeline.
Yes. The tube will just detect, depressurize, open the valve.
Okay. So this
So
is
any singular enclosure which requires a large discharge, we can use the indirect system.
okay.
And plus, if we require to use something like a powder, then you have a larger orifice which we can use. So we can use the indirect system.
Okay. So this is how the why don't you stop the alarm? Okay, viewers. So this is how the demonstration. I hope you enjoyed the session. For our Facebook viewers, we will take your leave. Do just remember to join us again on 14th October at 11 a.m. for yet another demonstration of kitchen suppression system. Our Zoom viewers can stay with us for a question and answer session. The Facebook viewer can send in their questions through comment section. Okay, so let's go to the.
Okay, we are ready to take questions. If there are any questions, we would like to have them now. You can put your questions on chat. Hello, Dan. You have a question for us?
Viewers, any question, you can send in your questions.
Okay, Mr. Suresh Sivarama has a question. What is the volume covered by a 4 kg cylinder? Are we talking about a direct system or an indirect system? If it's a direct system, a 4 kg system can, as per LPS, cover a 2 meter cube area. So a 4 kg would also be covering that much of an area in a LPS 666 system.
Then there is next question: what is the maximum size we have? We'll just scroll down in indirect system.
Rahul Gupta says, can you play the animated video of this system?
Yes.
This video is available on a website. The live demonstration would be available over there too. Khalid, the maximum size of the cylinder in an indirect system would be a 5 kg CO2 and a 9 kg powder or low pressure gas system, HFC 227EA or your floor ketone. Mr. Suresh, I just answered this. For a direct system, largest volume which can be covered, say you have a panel with a lot of enclosures. So the largest volume within this enclosure should be about 2 meter cube for LPS 1666 system. If you choose to use 4 kg, it will be the same volume. And the limitation of how many enclosures can be covered is derived from the tube length. So it should be within the tube length prescribed in LPS 1666.
Yes, we just opened the, the question is, the discharge system, your panel door is open and yet it can put a fire. So we just open the door so that our viewers can see, otherwise it will be always closed when the actual scenario is there. Is that enough?
Dan, this was answer to your question that we had kept the door purposely open just to show you that, how the discharge is taking place. So normally all the doors would be closed.
Next question is the monitor. always placed at the no.
Mr. Coutinho, in the monitor always placed in the equipment we are protecting, or can it be placed in the control room? See, monitor is usually placed close to the protected area, and it is not necessary it has to be put onto the panel itself.
It can be also in the control.
If the control room is close by, we can put it over there. Otherwise, if you want to take the signal from the control panel to the control room, then we can extend a wire through a non-potential output, and which I believe you want to put in the fire alarm panel.
Next is cool down.
Mr. Suresh, meaning 2 kg and 4 kg has the same volume. No, Mr. Suresh, 2 kg and 4 kg have different volumes. It's just that as per LPS 1666, the system was defined to for a maximum volume of 2 meter cube. But it is not that 2 meter cube is the only volume. You will have other enclosures within the panel too. So you use 2 kg or 4 kg. 2 kg would suffice in this case in all scenarios. 4 kg probably you might be using, say if you have say some kind of leakage or an opening in the panel which is quite big.
So in this we can highlight about this forced ventilation and open ventilation.
Mr. Tan, this is yes, using a high capacity, you can at least maintain the desired concentration for the time required for extinguishment. So hence the 4 kg.
Also, the CQRS is certified by LPS 1666 for both open and
closed enclosures.
Enclosures and forced
and natural ventilation. Khalid Ifar to all panelists, what is the maximum length for the low and high pressure system? Lengths as to HST or pipe lengths. For now, I can say for a direct system, it is defined that you can have a maximum of 4 branches with length of each branch coming to 10 meters. That is from valve, on the valve till the end of line of any of this branch. I hope, Mr. Khalid, I have answered your question. Okay, Mr. Tan, how fast will the tube detect the fire? This is a very interesting question. See, since the tube is bursting because of the temperature of the fire, the proximity of the tube to the heat source will dictate how fast or slow it will happen. Okay, but our best intention should be that the tube is closest to the heat source. And as you saw as a result that, depending on what temperature the source is at and what distance the tube is from the source, it will be relative as to how fast or slow it happens. But I would say between 0 to 10 seconds would be maximum.
If the ambient temperature is somewhere around 150 to 180, so
that could also happen if there's a rapid rise in temperature.
Yes, it will take faster. Yes, for direct discharge system, will you have a sounder as well? Yes, we will have.
We can provide both sounder and a beaker.
Oh, that's a good question.
See, our response panel will be able to monitor up to 4 systems per panel. Keeping in mind, all these systems should be in close proximity. That means each system comprises of your agent cylinder, your HST, that would be one system. Okay, for a direct system, we say maximum tube length of 40 meters. This is how it is defined. Say if you had 2 branches extending from either side of the valve, okay, each of these branches being 10 meters, then we have to subtract the common branch length.
say the common branch length is 1 meter and you are extending on either side of the valve, then your first branch would be 10 meters and your second branch extended from the T would be 9 meters. So that will give you a 10 and 9, 19. And if you were to take it in practicality, it would come to about 38 meters to the max.
Okay, Pranav, there's a next question about certification.
How long should we check the tubing?
This is a automatic, pressure monitoring system, so you can always check the.
Mr. Tan, if this is about how do we check if the tubing is having appropriate pressure or not, then at the end of each tube, to the tube length, any one of the tube length, we can attach adapter to which we can connect a pressure gauge switch, and this pressure gauge switch will monitor and tell you in the response panel if the pressure is okay or not. Now we have a question, we don't have a name. Please advise the certification approval. Do we have any standards mentioned in NFPA for installation? See, mostly for an integrated system, the only standard which has been developed is the LPS 1666, which I know of. There is no other standard for an integrated system, and that too, it is available only for a direct low pressure system. As per NFPA, mostly we are looking at UL listed gases like HFC 236, 227EA, these kind of, and their coverage factors or their suppression concentration. That is what we are looking at.
How do you power the sounder and beacon?
Mr. Tan, see, the response panel has an inbuilt power supply. So this power supply can power the sounder and beacon on its own. So you do not require a separate power supply for this. Mr. Babak, do you have any technical document to give us for information about these packages? If you could detail and write into us what kind of technical details you want, we can always write back to you on. You can write to us as response@ceasefire.in. Mr. Tan, how do you power this? Okay, we have done all that. Do we have any technical documents? Okay, Mr. Sandeep, can we interface monitoring panel with fire alarm system? Yes, we can monitor. We can interface both the systems through a non-potential output from the panel. It can be taken through a input module on a addressable fire alarm system, and it can be integrated to a fire alarm system in such a way.
Yes. So both direct and indirect system must come with your suppression panel. Yes.
Yes, it's a good practice to use. It is not a suppression panel, Mr. Tan. It is more of a monitoring panel, and it heightens the reliability of the system. So yes, we do suggest it. Using input module of addressable fire alarm system, we have NONC output from our panel. That is, again, Mr. Tan, I will reply from another panelist. Do we have any more questions?
Okay. So that's it. Viewers, thank you very much for joining. And once again, do remember to join us on 14th October at 11 a.m. for yet another webinar series on kitchen suppression system. Thank you so much.
Okay, we have one more question. What are the details we can monitor in your panel? In a panel, you can monitor the valve position. As I told you, the integrated valve position can be monitored, and you can monitor the heat sensing tube pressure using a PGS.
Okay.
Thank you all for joining us. We are signing off from AI Center. Please join us again.
Thank you so much.
All cost questions can be put on our response panel, and the sales team will get back to you on that. Thank you all. Thank you so much. We'll end the session now. Bye.